we're going to bring together the idea of prime factorization and the ideas of GCF and LCM and how they all work together, just like we've done in class. So the first thing you'll need to do is break up your number into all of its prime factors. Its prime factors. Every number can be broken down into its prime factors. So for this one, you could either use 10 and 2 or 5 and 4. But my square is going to represent composite numbers. My circle is going to represent prime numbers. So whatever I put here has to be a composite number. Whatever I put here has to be a prime number, just for my brain's sake. That helps my brain reason this out. So if I did 2 and 10 to start this off, 2 times 10 does equal 20. So those are two factors that make up 20. 2 is prime, 10 is not. 10 has two factors. 2 and 5. Also, it has 1 and 10, but remember we don't include those because 1 is neither prime nor composite, and 10 is a composite number. So we're going to work with all of these prime numbers that can be multiplied together to give us 20. As I showed you in class, that 2 squared means the same thing as 2 times 2. It's just combining all the like terms and grouping up your numbers. So this would be our prime factorization for the number 20. And in this, we're going to find, if we have more than one number, we're going to be able to find our greatest common factor and our least common multiple. You could pick a really cool big number to do this with, and you think you're going to have this great big long tree. If you saw the 1 million we did in the hallway, it is crazy not as big as I thought it was going to be. So just know that a lot of times there's some rather large prime factors hiding in these numbers, maybe not so much with this one, but with other numbers. One number I noticed right off the top of my head is that 5 is going to go into that because I know my divisibility rules and see how they help me. And if I'm not sure how many times 5 can go into 205, even though I am, because I can break this number up right here. Wow, that wasn't the best. Wasn't even better. So if I break this number up right here, I'm using the mouse and my couch, so you're probably not going to be able to see this wonderfully. It's hard for me to write. I'm going to use that property that I know about kind of distributing out these elements. But this 20, 5 goes into 24 times, and 5 goes into 5 one time. If I do it the correct way, I say 5 goes into 2 0 times, 0, so on and so forth. And then when I bring down my 2 and my 0, I'm left with 20. 5 goes into 24 times. 20 minus 20 is 0, and I bring down my 5. 5 goes into 5 one time. 1 times 5 is 5. So I'm left with nada. 41 is my best answer for this, and if we remember something that I was just kind of hinting on, 5 times 41. Now let me just check this so that I'm sure that I'm still right here. 5 times 1 is 5. 5 times 4 is 20. Man, okay, wait. Now I know this is a prime. I know that this is a prime number. But 41 is such a big number. I thought for sure it must not be prime. But I'm sitting here going through my divisibility rules. I know it's not divisible by 2. Because it doesn't end in an even number. I know it's not divisible by 3 because the sum of the digits is 5, and to be divisible by 3 it has to be divisible by 3, the sum of the digits, and that's the same rule for 9, and 9 is not divisible by 5, so that also doesn't work. That rules out 6 too, because if it's not divisible by both of these, it can't be divisible by 6. It doesn't end in a 5 or a 0, so it's not divisible by 5. Not divisible by 10 because it doesn't end in a 0. And I could check my other numbers that I haven't really done here, but I also can check my sieve, and I know that 41 is a prime number. This is the prime factorization of 200 and 205. All that work for a little amount of factors. There's also another way to do this with the factorization ladder. We kind of briefly looked at this in class. And you start with whatever number you have, and you create your little ladder rung, whatever. And pull out the first noticeable prime factor that you can. I like to work with 2 first if that's possible, and then 3, so on and so forth. So I'm going to pull out a 2. It's obvious it ends in an even number, so this number is divisible by 2. 2 times 32 equals 64. If I don't know that, I can come off and divide that off on the side. I would actually need to divide it. I know it's divisible by 2, but I might actually need to divide it. Keep in mind that 2 goes into 6 evenly 3 times, and 2 goes into 4 evenly twice, so you really don't need to go through the whole long division thing if you're aware of that. So you have your 32, and the next step in this is to go through the same way. It continues and continues the same way. So you would find the next prime factor that goes into 32. Again, a 2 goes in there. It ends in an even number. So take your 2 out, and you're left with 16. And then take a 2 out of 16, you're left with 8. Take a 2 out of your 8, and you're left with 4. Divide a 2 out of the 4, and you're left with 2. These are all of your prime factors. The reason why I stopped here is because I know my next rung is going to leave me with a 1. So if you prefer to put this 2 right here, that's fine, and have your little candle at the top of your cake or whatever, your little 1 at the top of your cake. That's fine too. Whatever your method is good with me. So continue it until you're going to end up with that 1. And all of these are the prime factors. We have 1, 2, 3, 4, 5, 6 2's, and don't you dare tell me that 2 times 2 times 2 times 2 times 2 times 2 is 6. Because it's not. 2 times 3 is 6. This, we have to use that grouping property, that associative property in this, and we kind of got to group these numbers up. So we've got 4. You can do it any which way you want. This one's making me happy right now. And then I'll grab these 2 guys right here. They equal 4. 4 times 4 is 16, and then 16 times 4 is 64. So, double checking it just to make sure we did it right, and we did. So well done. That's the way you can use the ladder. So we could do that with 200. I'm not, because I want to show you this GCF idea. We learned the old way is to list out all the factors like you have here, all your factors for each one of these, and then find the greatest common one that they have. But there's another way to do this. It gets a little bit harder. With the GCF and LCM if our numbers get really big. We know for the least common multiple that we can list out all of our multiples, find the first one that they share, and it's 12. They also share others, but the smallest one is 12. So that's one method. But check it. If we have 108 and 120, and we are asked to find the least common multiple, that's a pretty difficult task. It's even a pretty difficult task to find the LCM as well. So the easier method is to use your prime factors if you're dealing with really large numbers like these. So if we use the prime factors, let me check and see if I did this. Yeah, to figure out 108 and 120, you could find an obvious factor that goes into both of these. You could use your ladder or your trees. 2 goes into 108. 2 goes into 10 5 times, and 2 goes into 8 4 times. So I have 54 over here. And 54 is obviously a composite number because it ends in an even number. 2 is prime because it only has 2 factors, 1 in itself. If you break 54 up into its 2 factors, or 2 of its factors would be a better way to say that, you know 2 goes into 54, so you could divide it in there and see how many times it goes in. 2 times 2 is 4, and 2 goes into 14 7 times, so you have 27 and 2, and 27 is divisible by 9. 9 times 3 equals 27. 3 is a prime number, and this was our commonly missed one on the ticket out the door. 9 is not a prime number, fellas and ladies. It is a composite number. It has 2 factors, 3 and 3. Circle those 2 factors and you have it all broken down. Come over here and do the same with your 120. And 120, an obvious choice, maybe an easier choice for you would be 20. 20 goes into, well, that might not be an obvious choice for you. So let's do a more obvious choice, 2. 2, this is clearly divisible by 2. You could have also picked 10 there. It's an obvious divisible by 10. If you divide it into 12, it goes in 6 times, and it goes into 0 0 times. So 60 is going to be your quotient there. 2 is prime, 60 is composite. 10 times 6 equals 60. And if you break 10 up, it goes 5 and 2 multiplied together give you 10, and 2 and 3 multiplied together to give you 3. And you have all of your prime factors right here. So once you list them all out, you can find the ones that they share in common. I've already circled them here for you to see. And that way you have your GCF. If you remember from class, that's your GCF right there. The ones that they have in common, that 2, and that 3. So the GCF for this would be 2 times 2, which is 4, and 4 times 3, which is 12. And then to find the LCM, you have to take into account all these leftovers. So you'd have to take into account the 2 and the 5, and the 3 and the 3. So you'd have to multiply your 12 times 2, that product by 5, and then multiply that product by 3, and that product by 3 again. So what you would do next is take your greatest common factor, which we said was 12 already. We knew that that was 12. And multiply it by your other leftovers. I just grouped these based on where they laid out in the numbers. So 9 is 3 times 3, and 10 is 2 times 5. So the most obvious choice for me in grouping would be 9 times 10, which is 90, and then I would actually come over here and multiply 90 times 12. 0 times 2 is 0, and 9 times 2 is 18. Save this place because you're not using any tens, and you multiply your 1 times your 0, and you get 0, and 9 times 1 is 9. Add up all of your numbers, and you're left with 1080 as your least common multiple. Now I think you would get frustrated if you had to write out all your multiples to find it the other way. So this way would definitely be easier in terms of finding those numbers. So use your prime factorization to find the ones that they have in common first, find the greatest common factor, and then take into account all these extra guys when you're finding the LCM. Take into account all your leftovers. It's the same with the prime factorization ladder. You do it the exact same way. You're still finding the prime factorization no matter which method you use. If you want to just go ahead and start your ladder off with both of your numbers at the bottom, you're going to go about it the same process that you would before. Just keep building. But find factors that they both have in common this time. So 36 and 90 both have a factor of 2, so you could divide that out of both of them, and this is what's left. Divide 3 out of these two because they both can be divisible by they both are divisible by 3, so on and so forth. So you have all prime factors, and you can see that these are the ones that they have in common, and these are the extra folks left over to help you find the LCM. I hope this has helped.